Hello students, this is Shweta Patil and I welcome you all to the video lecture on computer organization. Today in this video I will be explaining about third module unit called as memory system consideration. So what is memory system consideration and how memory controller plays an operation? Let's look at this. Primarily, static memory, as we all know, is used for faster operation. So, where the static memory will be used? Static memory mainly will be used in primary requirements such as cache memories because they need faster operation. Where all faster operation is necessary, only there will be making use of static memories because of its high cost and size complexity. If speed is not the constraint, then we can make use of dynamic RAMs. So dynamic RAMs are the predominant choice for implementing main memories. So the main memories are making use of dynamic memory, isn't it? So this dynamic memory chips are using multiplexed addressing. Multiplexed addressing indicates same number of pins are used for multiple operations. So here address will be mainly divided into two parts. Actually what happens is the processor will be sending the address. As you can look at the block diagram, the processor will be sending the address and this address will be divided into two address bits. One is higher order address bits and the other is low order address bits. So higher order address bits are normally used to select the rows, and this row selection can be done by making use of a control signal called as RAS. And lower order address bits will be selecting the columns, and these addresses can be latched using CAS control signal. Okay, so thus we are dividing the address into two parts, that is high order address and low order address. This multiplexing of the address bit is usually done by the memory controller unit. You can look at in the figure, in between the processor and memory we are having a control unit called as memory controller unit. Okay, this controller will be accepting different signals from the processor. You can see in the figure the processor is sending the address, it is sending read or write signal, it is sending request signal and clock signal to the memory controller. So memory controller accepts the address, it accepts what type of operation has to be performed, whether read operation has to be done or write operation has to be done. Upon a request, what the memory controller will do, the main primary functional of memory controller is now to divide this address. So when it gets to know which operation has to be performed and when it collects the address, it divides the address into row and column addresses and makes the memory to assert the row address or the column address by generating RAS bar signal and CAS bar signal. So memory controller provides RAS and CAS timing in addition to its address multiplexing function. It also sends R/W bar and CS, that is control signal, to the memory. So CS signal is usually active low. Okay, hence it is denoted as CS bar signal. So the memory receives RAS bar signal. When it receives RAS bar signal at clock pulse, the address on the row or column address lines are taken as row address, and when CAS bar signal is sent to the memory at a particular clock pulse, at that time the address on the address row or column address will be taken as column address. Thus a particular row and column will be selected and the mentioned operation, whether read operation or write operation, that will be performed. Okay, then if it is a read operation, then the memory will be keeping the data from the specified row and column onto the data and send it to the processor. If it is write operation, the processor, along with sending address and all different signals as read or write, request and clock, it also sends the data along with the address, and this data will be now taken and written into the memory by the memory unit. So this is how the memory controller is useful for performing multiplexing operation on the address and performs read and write operation. Thank you.